Find the area of the largest rectangle that can be inscribed in the ellipse x squared over a squared plus y squared over b squared is equal to 1. First thing I'm going to do is introduce a set of x, y axes. And then, as a reminder, a, the base of the denominator under x squared, is the number of units I will go left and right from the center to get to the vertices of my ellipse. And then b, the base of the denominator under y squared, is the distance up and down I'm going to go. You may remember from studying conics, the number a, or a squared I should say, isn't always x squared, isn't always under x squared. Sometimes a squared is under y squared. The deal is that for an ellipse, a is bigger than b, which means what we have is a horizontally oriented ellipse. So there we are with our horizontally oriented ellipse. Now we're going to inscribe a rectangle inside this ellipse. Now whatever the dimensions of this rectangle are, they're smaller than 2a by 2b. I don't really care what the dimensions are. What I do care is that I can identify a point in the first quadrant and identify it as x comma y. Then I know that the area of the rectangle is equal to 2x times 2y. Where are the 2's coming from? If this is the x coordinate, then that's the distance between the y-axis and that point. We have a whole other distance to the left of the y-axis, so hence our 2x by 2y. So the area for our rectangle is 4xy. If you've been paying attention, then you'll know this is too many variables. I need to trade out either x or y. And we have this constraint here. Once again, a constraint is an equation that connects x and y. Well, x and y in this case. Everything's pretty much symmetric in terms of x and y, so it doesn't matter if we solve for x or solve for y. So I'm going to go ahead and solve for y because I'm used to things being in terms of x. So y squared over b squared is equal to 1 minus x squared over a squared, which means that y is equal to plus or minus the square root. You know what? I'm going ahead of myself here. Let's say y squared is equal to b squared times 1 minus x squared over a squared. That way, when I square root, and you know what, I was about to write plus or minus, but we've already decided that we're looking at something in the first quadrant. So since we're using y as a distance from the x-axis, we can go with the positive, and we know that our height is 2y. We already have that built in. So y is equal to, well now look, the square root of b, the square root of b squared is b. And then I have the square root of 1 minus x squared over a squared, which is perfectly fine. However, if inside the parentheses I decide to get common denominators, then I can take that common denominator of a squared and square root it. The result is I can say that y is equal to b over a times the square root of a squared minus x squared. That's pretty tidy. Now I can write down the area as a function of x and say that it's 4b over a times x times the square root of a squared minus x squared. Now that I've gotten it to this point, and this is the variable x, I want to make sure that's clear. Now that I've gotten it to this point, I'd like for you to go ahead and finish the problem, keeping in mind that we're asked for the area of the rectangle. A prime is 4b over a times, and I had to use the product rule. So the square root of a squared minus x squared over the square root of a squared minus x squared. Don't forget uv prime for this term here involved an x, but then there was the chain rule, so I had negative 2x, and then the 2's divided out. For a prime to equal 0, well, I went ahead and got common denominators. And ultimately we end up with x is equal to a over the square root of 2. Now, our area was 4xy. I have x, I need y. We have our constraint. X squared over a squared plus y squared over b squared equals 1. So When x is equal to a over the square root of 2, it turns out y is equal to b over the square root of 2. Substituting those values in place of x and y in our expression for the area of the rectangle, we get that the area is equal to 2ab, which is kind of nice because up here at the derivative, it was looking kind of bad. And this is a really elegant answer. So the largest area is 2ab.